Hello students. So today we are going to discuss about Coulomb's law. Now the students who are already in class 12 know that this is a part of electrostatics. And in electrostatics, the first important topic that you have to know is Coulomb's law. So let's see what this law tells us. Now Coulomb's law was given by Charles Augustin de Coulomb in the year of 1785. Now let's see what this law tells us. Coulomb's law tells us two stationary point charges. Now remember one thing, Coulomb's law has to be for two stationary. It has to be two charges. Coulomb's law works for two charges, not more than, of course it can work for more than two charges, but the basics of Coulomb's law is only for two charges. Now remember, it has to be stationary point charges. Okay, so stationary point charges. We know that in electrostatics, the charges are stationary. Okay, unlike current electricity. In current electricity, we take the charges to be moving. We take moving charges. But in electrostatics, we take the charges to be stationary. So this thing, most of the students, I have seen that this thing, most of the students, they ignore or they neglect. But this is the first important thing that you have to remember. Coulomb's law is only for stationary point charges. Okay. Now, if we have a distribution of charge, then we work in some other way. Okay. Now it says that for two stationary point charges, okay, so if we have two stationary point charges, they will attract or repel each other with a force. Okay, now this force is also known as the electric force. This is also known as the electric force, which is directly proportional to the product of the charges, okay, and is inversely proportional to the square of the distance between them. And this force acts along the line joining the two charges. So what does it mean actually? Now suppose we have two stationary point charges. Remember, once again I am giving stress on the point, it has to be stationary point charges. Okay, suppose this is charge Q1 and at a distance there is another charge Q2. Okay, so these two are two stationary point charges. So Q1 is one charge, Q2 is another charge. We don't know what is the nature of the charge. That means it can be either plus or minus. Now they are separated by distance r between them. Okay, there is a distance of separation of r. Now Coulomb says that. Now also remember this, there is no direct proof of this law. It can be proved from some other ways. Of course, we'll be learning later on from Gauss's theorem. Coulomb's law can also be proved, but there is no direct proof of this one because Coulomb has proved this one on the basis of experiments. Okay, so this is an experimental based law. Now, so if we have two charges Q1 and Q2, okay, so Coulomb says that these two charges, these two stationary charges, they are going to attract or repel each other with a force, and this force, as I already said, this is known as the electric force. Now when it will attract, when it will repel, I think all of you know. If these two charges are same charges, like charges, that means suppose this is positive and positive, of course positive positive or negative negative, they are going to repel each other. Okay, so like charges repel each other. And if these two are unlike charges, okay, so if one is positive, one is negative, they are going to attract each other. So unlike charges, we know attract each other, so whatever it might be, so they will attract or repel each other with a force. Now Coulomb said that suppose the force of attraction or repulsion between them, so for now I am saying suppose the force is F. Okay, the force is F. Suppose these two are, suppose unlike charges, they are attracting each other with a force. Now this force, they will be same for both the point charges. That means both the point charges, they are going to attract each other with the same force. So this is the next important thing that you have to know. They are not going to attract each other with different forces. They are going to attract each other with the same force. So this Q1 and Q2, they are going to attract each other with the same force F. Now Coulomb says that this force will be directly proportional. You know, this is the sign for directly proportional. So this force will be directly proportional to the product of the charges. Okay, so this force will be directly proportional to the product of the charges. Okay, so more the amount of charge, more will be the force. So this is what it means. So more the amount of charge, more will be the force. Remember, this force depends on both the, so the magnitude of both the charges, not of a single charge. This force depends on the magnitude of both the charges, and it is also inversely proportional to the square of distance. You know, this is a non-contact force. Of course, those who are familiar with the term contact forces and non-contact forces, this is a non-contact force, and most of the non-contact force, they are proportional in this way, they depend on this way. The non-contact force is always inversely proportional to the square of distance, okay, which means that if you increase the distance of separation between these two charges, the force is going to reduce, okay, by a factor of 2. Remember this one, by a factor of 2. Okay, so the force is directly proportional to the product of charges, and the force is inversely proportional to the square of charges, which means that more the magnitude of the force, more the magnitude of the charges, okay, more the magnitude of the charges, more will be the force of the attraction or repulsion, whichever is acting between them. Okay, and more the distance of separation between them, less will be the amount of force. Okay, but remember, this is not exactly that inversely proportional to distance, this is inversely proportional to the square of distance. Okay, that means if we double the distance, the force is going to reduce to by 1/4. Okay, the force is going to be 1/4. If we make the distance half, the force is going to get doubled. This is very important. So these two was said by Coulomb. So let it be equation 1 and equation 2. Now here this is only Coulomb's law, and then we have one more line. The force always, remember this one, the force always acts along the line that is joining the two charges. Okay, so this is one charge, this is another charge. If we join them by a line, the force will always act along this line. The force is not going to act along this line or any other line. Okay, so the force is always going to act along the line that is joining the two charges. Remember this one. So this is what is all about Coulomb's law. Now we are going to go into little bit further more topics, and let's see what are the things that we can get from this Coulomb's law. Now see, if these two statements we can write from Coulomb's law, we can also write this one, that force will be proportional to Q1 Q2 divided by R square. Okay, so this one you know that if this is proportional to this one, if force is proportional to 1 by R square, so of course force will also be proportional to Q1 Q2 divided by R square. That means the product of these two factors. Okay, now to remove proportional sign, we can give a constant over here. Suppose the constant is K. So K, Q1 Q2 divided by R square. Okay, so this is the formula that was given by Coulomb. Now what is K? K we can write K equals to, this is the constant of proportionality. Constant of proportionality. So this is K. Okay. Now in many physics formulas you have seen that this value of K is actually 1 or something else, but over here this value of K is extremely important. Okay. This value of K is of extreme importance because this value of, we have a definite value of K over here. Okay. Now what is this value of K? Experimentally it was found to be the value of K. Okay. Value of K. What is the value of this constant over here? So the value of K is 9 into 10 to the power 9. This is the value of K. Okay, and we also have a unit for this one. This is a dimensional constant. Please students keep it in mind. This is a dimensional constant. That means this constant is not dimensionless. It has a dimension. That means it has a unit over here. Okay, so the value of K is 9 into 10 to the power 9. The unit is Newton meter square Coulomb to the power minus 2. Okay, now how did I reach this unit? Newton meter square Coulomb to the power minus 2. We will be coming to this one. Just after a few minutes I will be telling you this one, how we get this one. Newton meter square Coulomb to the power minus 2. But for now, just to keep it in mind, this is the value of K over here. Okay, now the most important thing about Coulomb's law. Now those who are following this video, I hope those who have already studied gravitation, okay, I hope you can find a very striking resemblance about that means in between Coulomb's law and gravitational law. Now gravitational law is also very similar. Okay, gravitational law was given by Newton. It says that if we have two masses, then the two masses will always attract each other with a force which is known as the gravitational force, and the gravitational force is proportional to the product of the masses, and it is also inversely proportional to the square of distance of separation between them. And in gravitational law also we get a constant over here, that is the universal gravitational constant, capital G. Okay, so you also get a constant over here, but there is one important difference between gravity. There are many differences, but one important difference between gravitational law and Coulomb's law. Gravitational law does not depend the force of attraction. It does not depend what medium is between the two charges. Okay, it works the same for any medium, vacuum, medium, anything. The gravitational law, the force of gravitation, it will be same, but Coulomb's law is different for different medium. Okay, it depends on what medium is present between the two charges. Okay, what medium I have kept between the two charges, on that medium this force that is acting between the two charges, that is going to depend. Okay, how? For that, let us understand what this value of k means. So k, as I told you, the value of k is 9 into 10 to the power 9 Newton meter square Coulomb to the power minus 2. Also, the value of k was found to be 1 divided by this constant has a particular formula. Okay, the formula is 1 divided by 4 pi epsilon naught. Okay, now what is this one, epsilon naught? Those who don't know about this one, they will be thinking that what is this epsilon naught. I will be telling you what is this epsilon naught. So value of k is 1 divided by 4 pi epsilon naught if there is a condition, if the medium is vacuum. That means if there is vacuum between the two charges. Okay, if there is vacuum, or you can consider air, because you know there is not much difference between vacuum or air, we consider them to be same. So if the medium between these two charges is vacuum, then we take the formula of k to be 1 divided by 4 pi epsilon naught. Okay, now if there is any other medium, there can be any other medium also. Suppose two charges, if you keep it inside water, or if you keep it inside oil, or if you keep it inside any other medium, or suppose if there is a dielectric, or now what is a dielectric? If there is some non-conductor, suppose if there is some insulator between these two charges, that also it can be. Okay, so there can be any medium between the two charges. This one I told, if there is vacuum between the two charges, then we will use, I think you can understand this 4 pi is a constant. Okay, so 1 divided by 4 pi, 4 pi is a constant, this epsilon naught is a new term to you. So if there is vacuum, then we will use this epsilon naught. What is this epsilon naught? I am going to tell you. Okay, now, so actually the formula for Coulomb's law, ultimately the formula for Coulomb's law we can write in this way. Okay, the main formula is k into q1 q2 divided by r square. So I think we can write this one 1 divided by 4 pi epsilon naught q1 q2 divided by r square. Okay, so this is the formula. Either we can write this one, or we can write f equals to 9 into 10 to the power 9 q1 q2 divided by r square. Okay, okay, fine, no problem. Now also remember, over here the value of 9 into 10 to the power 9, I have written the value of k. This is also if the medium is vacuum. If there is some other medium, then this value is going to change. Okay, so as I said, Coulomb's law, it depends upon medium to medium, what medium is present between them. Okay, that time I forgot to tell you, this value 9 into 10 to the power 9, this is only for vacuum. If the medium between them is vacuum, if there is some other medium, the value is going to be different, just like this one. Okay, so if this is all for vacuum, I am writing. Okay, this is all for vacuum, remember this one. So this one we can write the formula for 9 into 10 to the power, formula for force 9 into 10 to the power 9 q1 q2 divided by r square. Once again, for it is for vacuum. Okay, now from here just we can get the definition of 1 coulomb. Okay, the definition of 1 coulomb. You see, if we take two charges, that is suppose 1 coulomb. Okay, suppose q1 is 1 coulomb, q2 is also 1 coulomb, suppose, and the distance between them, suppose it is 1 meter, suppose. Okay, so this is 1 coulomb, this is 1 coulomb, and suppose they are separated by distance of 1 meter. So 1 into 1 divided by 1 square, so we will get 1 over here. So then force will be equals to 9 into 10 to the power 9, that is Newton. Okay, this will be the force. Okay, this will be the force. Now how we can define 1 coulomb? So we can define 1 coulomb in this way, that 1 coulomb is that charge. Remember, okay, once again I am repeating, 1 coulomb is that charge. Okay, so this is 1 coulomb, this is also 1 coulomb. Suppose if we consider, okay, we can so define 1 coulomb in this way, that 1 coulomb will be that charge which, okay, when placed at a distance of 1 meter from another 1 coulomb, okay, 1 coulomb is that charge which, when placed at a distance of 1 meter from another similar charge or from another 1 coulomb, then they are going to attract or repel each other with a force of 9 into 10 to the power 9 Newton. Of course, there has to be vacuum between them. Okay, once again I am saying there has to be, if there is vacuum between them, so if they are placed at a distance of 1 meter, 1 coulomb and 1 coulomb, then they are going to attract or repel each other with a force of 9 into 10 to the power 9 Newtons. Okay. Now let's discuss about this epsilon naught. As I told you, this epsilon naught is known as permittivity of free space. This is known as permittivity of free space. So, permittivity of free space. Now, what is the meaning of this permittivity of free space? If there is any other medium other than vacuum, if there is no vacuum, then we are not going to use this epsilon naught. Then we are only going to use epsilon. Okay, free space over here means vacuum. Okay, free space over here is vacuum. If we have any other medium, then we are going to use the term permittivity of that particular medium. Okay, but now we are considering vacuum. Okay, if there is some other medium, how we will use? We have to come to some other. We will be using some other thing that is known as the dielectric constant. I will be telling you later on. But for now, I am just telling you about free space. So epsilon naught over here we are going to use epsilon naught. Okay, just we say it in this manner. Epsilon naught means permittivity of free space. Now, what is the meaning of this word permittivity? Permittivity, this particular word permittivity, in many books I have seen that it is given wrong, or it is not written at all on what is the meaning of this permittivity. Now, permittivity means, okay, it can be permittivity of free space, it can be permittivity of, say, of some any other medium, it can be anything. Okay, so what does this mean, permittivity? Permittivity, it's basically a material's ability to pass the electric fields. Okay, so those who are familiar with the term electric field, they will know. Those who are not familiar, no need to worry, in the other videos we will be able to know. You see, when these two charges are placed at a distance, okay, there are going to be electric fields. Okay, you know, if there are two magnets, they are magnetic fields. In a similar way, if there are two charges, then they are electric fields. There are electric fields which are acting between the two charges. So if there are two charges, there are electric fields between the two charges. Okay. Now, any particular medium, it can be vacuum, air, or any other medium. Any medium must have an ability that how much electric field the medium is going to allow. Okay, medium does not allow all electric fields. Okay, medium allows some electric fields or some particular electric field. So it depends on the medium how much electric field it is going to allow. Now, epsilon naught is such a constant which basically tells us, okay, that how much electric field it is going to permit. That's why it is known as the permittivity. Okay, permittivity of free space or for any other medium. Fine. So that's all for epsilon naught. So this is epsilon naught. Okay. Now, what is this value of epsilon naught? How do we get the value of epsilon naught? Okay. Just see value of epsilon naught. Value of epsilon naught. Okay. See. Now we know that K is equal to 1 by 4 pi epsilon naught. From here we will get epsilon naught will be equals to 1 by 4 pi into K. Okay, no problem. Now, epsilon naught is going to be, you see, epsilon naught is, we know that the value of K, as I already told you, the value of K is 9 into 10 to the power 9. This is the value of K. Okay, 9 into 10 to the power 9. Okay, this much will be the value of K. Now, if you calculate this one, we are going to get 8.85, okay, into 10 to the power minus 12. And remember, this epsilon naught is also a constant. Okay, epsilon naught, and also remember epsilon naught is for vacuum. This is also a constant, and over here the unit will be Newton minus 1, meter minus 2, Coulomb square. Okay, this will be the value of epsilon naught. Okay, so this is the value of epsilon naught. At last, I told you that how I got this unit. I will be telling you how I got this unit and also this unit. this unit and this unit, how we derive these two units, I am going to tell you. Just see. If we know the unit, we can also know the dimensions. So unit and dimension of K and epsilon naught. Unit and dimension of K and epsilon naught. Now see, force, the electric force which is acting between the two charges, its value is given by K into Q1 Q2 divided by R square. Okay. Now from here we are going to get K will be equals to F into R square divided by Q1 Q2. Now for the unit, F means force, so Newton. R means distance, so meter square. Okay. Q1 Q2, it's a charge, we know the SI unit of charge is Coulomb, so Coulomb square. So Newton meter square Coulomb to the power minus 2. So this is the value of K. Okay. Now I hope all of you know how to calculate the dimension. So dimension also you can easily calculate. So if you calculate the dimension, you will get over here the dimension of K will be. Once you know the unit, easily you can put the dimensions of those units and you can easily calculate the dimension. The dimension will be M L cube T to the power minus 4 A to the power minus 2. Okay. So this is going to be the dimension of K. Right? Now for the unit and dimension of epsilon naught, that is also very easy. We know that K is equal to 1 by 4 pi epsilon naught. Now from here we can see epsilon naught is going to be 1 divided by 4 pi into K. Okay. Now see, this 4 pi does not have any unit. Okay. So this 4 pi does not have any unit. So the unit of epsilon naught, will be 1 divided by the unit of K. The unit of K is Newton meter square Coulomb to the power minus 2. It is very simple. So Newton minus 1 meter minus 2 Coulomb square. This is the unit of epsilon naught. And the dimension of epsilon naught is just the inverse of the dimension of K. Okay, just the inverse of this one. That will be M minus 1 L minus 3 T to the power 4 A square. This is the dimension of epsilon naught. Okay, so this was all about Coulomb's law. Now this law is basically for if the two mediums, if we have two stationary point charges, then the basic law is the 2 point charges, they are going to attract or repel each other with a force. So that's all for today's video. Thank you very much. If you like the video, please like and subscribe.